Anatomy of a skeletal muscle.
First, you have your muscle, which is wrapped by epimysium. Within your muscle, you have fascicles, which are wrapped by perimysium. And within the fascicles, you have muscle cells or muscle fibers. Which are wrapped by endomysium.
Anatomy of a muscle fiber.
Each muscle cell is made up of a thin filament called actin, which is a protein. And inside each actin protein is a thick filament called myosin, which is also a protein. Each band of actin and myosin is called a sarcomere. Skeletal muscle contraction.
A skeletal muscle must be stimulated by a nerve, specifically a motor neuron, to contract. The connection between the motor neuron and a muscle fiber is called the neuromuscular junction. Between the end of the motor nerve and the muscle fiber is a narrow space called the synaptic cleft. When an impulse reaches the end of a motor neuron, it causes small vesicles to release a chemical messenger or neurotransmitter called acetylcholine into the synaptic cleft.
Acetylcholine quickly diffuses across the synaptic cleft, where it stimulates ion gate receptors and opens the gate, allowing sodium ions into the cell. This rush of sodium ions polarizes the cell, which allows the electrical impulse to be transmitted down the sarcolemma and into the T-tubules. This causes the sacs in the sarcoplasmic reticulum to release calcium ions.
The calcium in the cell binds to the troponin, which causes the tropomyosin to shift, revealing the actin binding sites.
Once the actin binding sites are revealed, the myosin head binds to it, creating a cross bridge. Then, the myosin head pivots forward, causing the actin to shift, which shortens the muscle. This is called a power stroke.
Once the power stroke has been completed, calcium returns to the sarcoplasmic reticulum. Then, ATP comes and binds to the myosin head, recocking it into its original position. This prepares the head for the next cross-bridge cycle.